Hello everyone, now I introduce the information interpretation function of PIE software. PIE software has a one-stop information interpretation capability for visual interpretation, automatic interpretation, and thematic mapping. First of all, we introduce that the visual interpretation is an annotation interpretation module. The annotation interpretation module has sub-functions such as annotation, information extraction, and font setting. First, we load the image to be interpreted. Annotation can mark objects that are visually interpreted. It also draws point elements, line elements, polygon elements, arrows, text, and so on. We can draw them separately. We can use it to modify elements, attributes such as color, size, and so on. We can export and save the label elements. We can remove the label elements. The information extraction module provides 4 functions: Magic Wand, Reshape, Clicked Element, and Vector Generation. The Magic Wand can quickly capture the edge line of the object and extract the elements. We click the Magic Wand button and click the left mouse button on the element to see the edge line of automatically generated element. Reshape is to make appropriate modification of extract elements. We click on the Reshape button and then draw the crop line on the element, which will automatically cut out the smaller area. Click Element is to cut the extract elements. We clicked on the Clicked Element button and draw a crop line on the element to split the single element into 2. The vector generation function is to convert the extract elements into vector elements. We click on the vector generation button and then a dialog box will pop up to set the name and the path of the vector file in the dialog. Then we click Save to perform the vector generation operation. After the vector file is generated, the system can read it automatically. The above is the introduction of an annotation function, followed by the vector process. The PIE vector process module is also mainly used to access information interpretation. The vector process group includes create layer, vector editor, tools, snapping, convert data, vector analyze function, and other submodules. First, we need to create a layer or load an existing vector layer. Now we choose to create the new layer. We click on the Vector Creation button of the dialog box. Will pop up Output file. Setting the path and the file name for output shape file. Coordinate system. Set the coordinate system of the shape file. Element tab. Select a vector layer tab from the drawn-down list. PIE is able to create a new point layer, new polygon layer, and a new polygon layer. Here we choose the polygon element. The same is true for the creation of point elements and polygon elements, the line elements. Attribute file. Edit the attribute file of the shape file. We click the Add button and proprietary message box will pop up. We can fill information such as name, lines, types, and so on. Here we add 2 attribute fields. Of course, we can also delete the file. We only need to select the file to be deleted, and then click the Delete button and delete the file. After all parameters are set, click the Open button to create a new vector layer and load it into the layer list automatically. Next, we will start vector editing. We need to click the Start Editing button in the Edit control to activate the vector editing functions. We clicked on the Add element and the corresponding window will be pop up on the right side of the interface. We can draw with polygon, rectangle, aspect, and round element tools. Now we use the polygon tool to draw multiple elements in turn. Next, we can decorate the elements in space. For example, element movement. Select a vector element you want to move, and then click Move to draw it into the desired location. Edit. Select the vector element you want to edit, and then click Edit. Both line and polygon elements are correspond of several nodes. In data editing operation, nodes can be added, delete, and move to change to the local shape of elements. Rotate. We can rotate the angle of the element by clicking the Rotate Element button. Cropping elements. We can click on the cropped element to draw a cropped line on the selected element, which can be used to crop the element. Merge elements. Select more than two elements. We can merge the selected elements by clicking the Merge Element button. After finishing the space decoration, we begin to edit the attribute information of elements. When we select the element and click on the attribute edit, we can edit the attribute information on the elements in the attribute window. Then we can fill in the attribute information for each element in turn. When it is done, we can wheel it in the proprietary sheet. Element. By right-clicking on the layer, we can open the proprietary table and view the proprietary information. We can also annotate elements. Right-click on the layer, click on the Annotate elements. You can see the annotated information. Next, we classify and render the elements. Right-click on the layer, open the attributes, select symbolization, and use unique value to classify and render. Hence, the DAO is the introduction of vector processing. Next, the automatic interpretation is image classification. The classification group includes unsupervised, supervised, region of interest, and post-classification functions. Unsupervised classification does not rely on adding peer knowledge. It will extract any hint failure within the image, which is also known as self-organization. The unsupervised classification distinguishes different features, but it cannot confirm the property of the extract features. The unsupervised classification group includes iOS data, k-means, and BP natural net functions. Supervised classification is a method to classify unknown areas according to the criteria determined by the peer knowledge of the simple categories and correct categories provided by the training field. It is also called the training classification model. The supervised classification model includes the distance and the maximum likelihood functions. Now we choose the distance classification method in supervised classification to demonstrate other classification methods operate. Similarly, supervised classification first need to determine the classification samples, which need ROI tools to produce samples, and unsupervised classification does not need. We load image to be classified. We click on the ROI tools and the dialog box will pop up. We can add a class sample of categories by clicking the Add button here. We can set the name and color of the sample. Then we use the sample drawing tool to draw sample on the image. In order to ensure the diversity of samples, we can draw more in the scope of the whole picture. Then we use the same method to draw the second kind of samples. We can complete the drawing of the categories of the sample. By clicking on the file, we can export this and save the same file. We can also open an existing sample file. Now, let's call the sample file that has been made. We have done a total of 5 types of sample before. Now, let's start classifying. We clicked on the distance category in the supervised category. Drop-down menu and the dialog box will pop up. We choose the classification file, selection area. The default is the form map classification, or you can customize the classification area. Choose band. The default is a 4-band classification. You can also customize. Select ROI. We read the file and add it by default. Classifier. Select classifier. We can choose a minimum distance or Mahalo-based distance. We can set file name and output files. After all parameters settings are completed, we click OK to perform classification processing. After classification, the system can read automatically. We can view the results with Swap tool. Next, we introduce the function of post-classification. The post-classification is to further process the result of the classification and improve the classification effect. The post-classification group includes class status, combined classes, save classes, clump classes, majority or minority analysis, converses mixture, and assign class color functions. We can choose the processing according to the classification results. Now, let's demonstrate and classify statics and color setting functions. We clicked on Category Status, and the dialog box popped up. We import the classification result area and click Start Statistics to perform the classification statistics operation. Statistical information includes number of categories, percentage of categories, and area of categories. We click on the classification information to save the statistics file. Next, we introduce the color settings of function. We clicked on the color setting and then pop up the dialog box. Now we can change the name and color of the category. Then we click Save to complete the color setting. The above is the demonstration of a software classification function. Next, we introduce the thematic mapping function. PIE software has an abundant categoric function and can easily produce thematic maps. The thematic mapping group include data view tools, layout view tools, data frame, map elements, align, order, distribute, thematic template, and thematic export functions. Next, we switch to view to drawing view and start making thematic maps. Data operation module has the functions of zooming in, zooming out, and full picture. It can adjust the data. Now we choose full picture zooming. View manipulation has the same function. We can use it to adjust the whole view. Now we also use full scale. Then we added the necessary drawing element in the map, retouching the module thematic map. We can add thematic map names, such as land use thematic map, and adjust the font size, color, location. We can add a north pointer, select the style, color, adjust to the appropriate position. Usually in the top right corner of the thematic map. We can add scales, select the styles, and adjust them to the right position, usually in the lower left corner of the thematic map. We can add scales, select the styles, and adjust them to the right position, usually in the lower left corner of the thematic map. We can add legends, select the styles, and adjust them to the appropriate position, usually in the lower right corner of the thematic map. In addition, we can add drawing date. After completing, we can save the thematic map template by clicking Save as a function in the System module for the next reviews. When drawing again, we can click on the thematic map template button and call the existing template directly. name. Finally, we clicked on the Export Map button to save the thematic map. Output path. Select the save path, name, and tap on the Export Pictures. You can export map to several raster graphic file formats: BMP, JPEG, PNG, and TIFF. DPI. Select the resolution of the export map. Values. The values of the output map can be displayed automatically according to the resolution of the dial map set in pixels. Height. We can automatically display the height of the output map according to the resolution of the export map. The unit is pixel. After all the settings are completed, click OK button to export the thematic map. That is all about PIE software information interpretation.